You are on a pier with some piers. You notice that it takes 3 seconds for the highest point of the wave, or crest, to travel the distance between the pilings of 5 meters. Each piling gets hit with a wave every 1.5 seconds, which is the period. What is the wave's velocity, wavelength, and frequency? I have listed the formulas we'll be using on this slide. We have that the velocity, which is the displacement over time, is equal to the wavelength, or distance before the wave repeats itself, so crest to crest in this case, divided by the period, or how long it takes a cycle to repeat, is equal to the wavelength times the frequency, or number of cycles per second. So how do we go about solving this one? We will start by finding the velocity of these waves. We can use the formula velocity equals the displacement over time. Plugging in our displacement of 5 meters between the pilings divided by the time it takes to travel between those pilings of 3 seconds, we get a velocity of 1.66 meters per second. Now we can use the formula, which is velocity equals the wavelength divided by the period, to find the wavelength. Rearranging this formula to get wavelength to one side, we get the velocity times the period equals the wavelength. Plugging in our numbers, we get 2.49 meters for the wavelength. Now for our final step, we can use the formula wavelength divided by the period equals the wavelength times the frequency. If we divide both sides by the wavelength, we are left with 1 over the period equals the frequency. Plugging in our numbers, we get a frequency of 0.66 Hz or 0.66 cycles per second. Poll update. That concludes this video. Hope you'll have earned a like, share, or subscription. If you enjoyed this video, you may enjoy one of these videos as well. Let me know how I'm doing in the comments down below. Thank you for watching.